But what I want to leave you with is the idea that there's more to machine learning these days than just optimizing your business metric. So at least moving forward, you need to take other considerations, right? So fairness, transparency, and explainability. So in particular, bias. So let's start treating biases as important bugs at the same level as we would security and privacy bugs. Of course, the challenge is that we hear a lot about bias. We hear a lot about fairness. But usually what we hear are anecdotes and stories, right? So there's not really a framework for how to address these problems. So fortunately, the machine learning research community has actually been engaged with this problem over the last few years. So let me go over a few ideas that you may want to take into consideration. So first, disparate impact. So this refers to the case where you have a model that appears to be neutral, but actually behaves very differently in different slices of your population. So, for example, you may have a predictor or a feature. Let's say it's the distance from a specific location. And let's say you have two income groups, right? So high income and low income. The distance distribution for the high income group is very different from the distance distribution for the low income group. So if you plug that into your model, of course, your model will behave very differently in these two different income groups. So what some researchers did a few years ago is provide people a systematic framework to identify things like disparate impact, and not just identify, give you a recipe for how to normalize your distributions and remove disparate impact. Error, right? So usually you optimize some machine learning error, some business metric, and you say, okay, now that I have it as low as possible, I'm done. But it turns out actually you can have a situation like this, right? So imagine you have, let's say, a predictive model for medicine, and you have most of your training data, which is in red, are for young people. And then you have fewer training or labeled data sets for your senior citizens. So obviously, when you plug this into your model, error for your younger people will be much lower than for your senior citizens, right? Because usually there's a correlation between the size of your training data set and the accuracy of your model. So again, the good news is that the research community has long known about this, and so they're starting to come out with strategies for how you can identify and remove this. So in particular, a group at Google gives you a step-by-step strategy for how to make sure that when this thing arises, you can have a framework so that the true positive rate for the different groups in your population are roughly the same.